Now we're gonna take the resultant of two forces meeting at a point analytically. The resultant of two forces is a single force that has the same effect as the two other forces or as the two original forces. If two forces meeting at a point are represented in magnitude and direction by the two sides of a parallelogram meeting at this point, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram which meets the two sides at this point. In parallelogram OACB, OA and OB represent the two forces F1 and F2. The angle between F1 and F2 is alpha. The diagonal OC represents the resultant, or to find the resultant, or AC is parallel to OB, so the force F2 can be represented in magnitude and direction by AC. Since OB is parallel to AC, so measure of angle OAC equals 180 minus alpha. This is 180 minus alpha. In triangle OAC, OA represents F1, AC represents F2, OC represents the resultant, or we can use the cosine law studied before in trigonometry to find the resultant, or in terms of F1 and F2 and the included angle alpha. Recall the cosine law to find the length of a side of a triangle in terms of the two other sides and the included angle. So A squared equals B squared plus C squared minus 2B times C times cosine of the included angle A. So A squared equals B squared plus C squared minus 2BC times cosine A. Now apply the cosine law on triangle OAC to find the resultant, or in terms of F1 and F2 and the angle alpha. R squared equals F1 squared plus F2 squared minus 2F1 times F2 times cosine of the included angle 180 minus alpha. Cosine 180 minus alpha equals negative cosine alpha. Let's change the sign of this term into positive. So R squared equals F1 squared plus F2 squared. Now change the negative into plus 2F1 F2 cosine. Change 180 minus alpha into alpha. And this is how to find the resultant of two forces in terms of the two forces and the included angle. R equals square root of F1 squared plus F2 squared plus 2F1 times F2 cosine alpha is the angle between the two forces. And tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. Theta is the angle between the resultant and F1. So F1 is the force adjacent to the angle theta. So F1 is the force adjacent to angle theta, and F2 the force multiplied by sine alpha up and by cosine alpha down is the other force, or the non-adjacent force. Now example 1. Two forces of magnitudes 8 square root 3 and 8 Newton act on a particle and include an angle of measure 150 degree. Find the magnitude of the resultant and the measure of the angle that the resultant makes with the first force. Say F1 is 8 square root 3 Newton and F2 is 8 Newton, and the angle between the two forces, alpha is the angle between the two forces, is 150 degree. Find the magnitude of the resultant, so we want to find the resultant R, and the measure of the angle that the resultant makes with the first force, so we want to find R and theta. From the previous rule, the magnitude of the resultant R is the magnitude of the resultant equals square root of F1 squared plus F2 squared plus 2F1 times F2 times cosine alpha. R is square root of 8 square root 3, so 8 square root 3 squared plus 8 squared plus 2 times the F1, which is 8 square root 3 times F2, which is 8 times cosine the angle between them alpha or 150. So times cosine 150. Simplify to get R equals 8 Newton. Now to find tan theta. Tan theta equals F2 sine alpha over F1 plus F2 cosine alpha. F1 is 8 square root 3 and F2 is 8. Tan theta equals F2, which is 8, sine 150 degree, the angle between the two forces, over F1, which is 8 square root 3 plus F2, which is 8 cosine 150 degree. So tan theta equals 1 over square root 3. Use the calculator, shift tan theta as 30 degree.